Hello YouTube! It's been a while since we spoke. Well, I spoke, you listened. I promised I'm gonna do a little video about how we created Getting Started, which is something that we created for GNOME 3.8. And I did a talk about it at LibreGraphics meeting in Madrid earlier this year, but not everybody was there. But you can still look at the talk. It's been recorded. I'm gonna put a thumbnail in here. You can click on it. If you're on a mobile device, there's gonna be a link in the description below. I talk about like why we created it, but I don't go deeper into individual aspects of the project, which is exactly what I'm going to do now in this video. So once you view the introduction, please come back and continue looking here. Let's dive in. Now, the whole project encompasses more than just videos, but when I focus only on these videos that we created, they all come together in the sequencer. The sequencer in Blender pretty much mimics what other NLEs, non-linear editors, do. It allows you to put together scenes, edit them, add sound effects, music, and then render the whole thing into a video file. Or in our case, we render into image stills and create what's called a mixdown, just the sound mix of the whole clip. Now, the whole project is split. Each video that help pages provide is separated into its own project file. And each of these project files includes scenes, so they're not static. They can be referenced, cross-file, and they are, in fact. And also there is a script file accompanied with every Blender project, which is used for the translation and rendering. But I'm gonna talk about that in the specific rendering section of this video. I'm going to talk about motion blur for a bit. It plays a major role in these videos because we wanted to keep the frame rate down so that the file size isn't dramatically high, but to get our visual system to perceive rapid motion as that without feeling choppy, we need motion blur. Now, there's several ways how to achieve that in Blender. One of the first ways that was implemented even before Blender was open sourced was the sampled motion blur in the default rendering engine. It looks perfect, but unfortunately it means that you have to re-render a single frame multiple times. Depends on how many samples you define, and this could dramatically increase the render times. I believe it was during the making of Elephant's Dream when Blender developers looked into a better performing motion blur solution when they came up with the compositor based one, when each pixel, apart from holding the color information, also stores its speed information in a separate buffer. So we have this vector buffer that we can later use in the compositor to blur it based on its speed. Now this works tremendously faster than the original way of doing motion blur, but it doesn't produce as accurate or nice results. You still have the option to define how many samples you want for the blur, but there are some cases where this doesn't quite work. In my case, it was when I was doing the clipping of objects using Boolean operators. It was just messing up my vector buffer, and some frames just looked really horrible. So I thought about just not doing motion blur for these scenes, but fortunately I dove into the new rendering engine, Cycles, which implements a completely new motion blur as well. Now in Cycles, motion blur is implemented as with the initial sampled motion blur in the Blender render engine, the default one, or the ancient one, I should say right now. So it's not done in the compositor. It can achieve very high quality if you increase the sample size, but the time required is not dramatically higher as if when you wouldn't be using it. Honestly, I can't tell whether motion blur actually adds any time to your render times. But there are downsides to it. Now, first thing is that I had to pretty much redo all the scenes that had issues with motion blur, redo them for the Cycles rendering engine. That means, you know, setting up materials differently. But it was worth it, and it taught me a lot about how materials work in Cycles. And right now, when I start a new project, I pretty much go for the Cycles engine, because the real-time preview it gives you, it's an accurate representation apart from motion blur, but it's just awesome. So what are the downsides? Well, right now the motion blur only works for two of the basic transformations. It works for moving and it works for rotation. Currently, objects that are scaled are not motion blurred, which is quite a bummer because surprisingly a lot of motion that we do in these videos are scale based, but still it's the best out of all the options that we have. Rendering is typically when all your work invested in setting up your scene, the materials, lighting, the animation comes together to produce the final output. We don't really have any light setup, complex materials or anything like that. So rendering is actually where the magic of translation happens. Now the way translations are done is very similar to how we did it with the static images. The static images also contain some strings that are translatable, and this is done by leveraging the structured document base for these images. There are SVG, there are XML documents, and so in here, if I was doing this from a personal project, I would probably go for something simple, like have all the text strings in a YAML file and just have you know, different languages, different versions of this file for different languages. Now, because we're doing it for the translators, they are used to their own tools, which, you know, is able to deal with XML files rather elegantly. We can provide some context for the translated strings, etc., etc. Now we do whitelist languages because we want to make sure that that the language actually works So we don't just blindly render everything that we have translations for. There are languages where things don't work. Either we don't have glyphs in the font for them, or they just are right to left languages, and it would require major restructuring. It's not like theoretically it is possible, but there's other things that we're busy with other than this one. So using their existing infrastructure, the translators can provide us with a translated XML file that includes all the strings that we expose in the animation. And so before rendering the animation, what we do is we walk that whitelist of languages and replace the strings based on that one translated XML file. We do that with Python, which is very deeply implemented in Blender. Like the whole UI is actually described with Python, and you can really do anything that you can do visually with UI you can do from the Python APIs. So before rendering, we translate everything, do other magical things as well, and then we render. We don't render into an animation file, which we used to do in the beginning. Instead, we render into image stills. This has many benefits. The major one being able to correct mistakes. If like I mentioned in the talk, if I'm giving an opportunity to mess something up, I do. So by rendering to image stills, I can simply delete the segment that's messed up and re-render the whole thing, and it's just gonna fill in the blanks, not re-render the whole thing. Also, there's technical limitations of what Blender can do on its own. If we want to rely on Blender to render this project, externally on like some build server or render server, we have to rely on the distribution provided binaries, and they can't have things like FFmpeg, and so we can't really multiplex audio into it. So we do that externally, either with FFmpeg or with GStreamer, depending on which one has more critical bugs at that moment. And that's essentially it. Currently I'm doing all the rendering of new languages, which probably isn't sustainable. It would be nice if we had a build server that would be doing all this, and adding a new language would not require depending on me messing something up. The last bit I'm going to be talking about is linking, which I did mention in my LGM talk, but didn't go into much detail. It is used for multiple things. For example, when the whole video starts, the whole getting started app starts, there's a little introductory video that sort of describes how to launch itself, so it's kind of meta, and this reuses a scene from how to launch application video. So I didn't want to just repeat the process or just create a duplicate of it and then lose the changes that I might have done and I did in the other video. So it's just linking to everything, to the whole scene from the other file. We use the same thing for branding. So for example, for rel, we're gonna be using the rel colors and typography that's different, and this is easily done with linking. So linking generally is used for larger projects to be able to work on assets that are reused in the animation. So for example, you link in some props, chairs, tables, everything, and initially they're very rough, and then the modelers add detail, tweak them. This is true for characters as well, character rigs, and animators work on it independently of the modelers. That's object level linking. Like I said, I'm linking whole scenes, which from the UI perspective, they're impossible to change. So you're linking something external, meaning that if you want to work with that asset, you have to open up that original scene from the original file that you're linking. But with scripting, you don't have to. You have the right to modify it, which we do. So at the time of opening, the file can include a text block, a script that does something when you open the scene. Now, because of how we version control things with Git, it's actually better to have this externally, because the Blender project files are binary, and it's easier to resolve conflicts when there aren't any. So we have the rebranding to be part of that rendering script that's external. So before rendering each script, before it gets translated, it's also being rebranded, and it's done transparently, and it just works. And that's it for this little look behind the scenes for getting started. If you're interested in learning the basic methods used for setting up the animations, check out my earlier series called Blender for Motion Design here in this channel, or come see me in Brno at Quadec, where I will be giving a talk or a demo on how we use Blender for motion design. Take care, guys, and see you around.